Alright, today we're going to talk about double angle formula and the half angle formula. So here are our double angle formulas. If we take a look, we know that it is a double angle formula because it is sine of 2x. So if you think double, we're timesing it by 2. So that's kind of giving me a giveaway that it is a double angle. So sometimes when you see that, that'll give you kind of that red flag that it's going to use the double angle formula. Okay, so these are the formulas. As you use them more and more, you'll kind of notice what's going on there. So first thing that we're going to do is simplify. So we're going to try to get as simple as we can by rewriting it and things like that. So if I look at this one, cosine squared of 7x minus sine squared of 7x, I kind of see that when I look at those formulas, and I notice that that looks an awful lot like cosine of 2x. So I go ahead and wrote down that formula. Now we're going to kind of notice that we have 7x here and 7x here in this spot for the x. Okay, so I know I can rewrite that as just cosine of 2, and then I'm going to put that 7x where that x would be. Now we can simplify that to be cosine of 14x, and then we're done. Okay, for this next one we see sine of 15 degrees, cosine of 15 degrees. I right away notice that that is very similar to what I noticed with, it kind of looks like sine of 2x equals 2 sine of x cosine of x. Now I notice that it kind of looks similar to that setup, but there's a 2 out front here. So I'm going to do a little bit of manipulation, and I'm going to divide both sides by 2. So I would have 1/2 sine of 2x equals sine of x cosine of x. Hey, now that I look at that, hey, this matches this right here. Just instead of x's, we know that we're going to use 15. Okay, so we can go ahead and rewrite this as 1/2 sine of 2 times 15 degrees. Now we can simplify that a little bit more. I'm going to come over here. So I have 1/2 sine of 30 degrees. Now, since I don't have an x, I actually have a number. I have 30 degrees. I have an actual measurement. We can actually simplify sine of 30 degrees. Okay? If we kind of go back to that unit circle, okay, 30 degrees, sine would be 1/2. Okay, so it'd be 1/2 times 1/2, which would give us 1/4. So essentially what I did is I rewrote sine of 30 degrees, knowing our right triangle, as just 1/2. So then I did 1/2 times 1/2, which is 1/4. And I simplified it all the way. So if you notice, the last ones were sine of 2x, cosine of 2x, tangent of 2x. Notice for these half angle formulas, it's just x over 2 instead of 2x. And that does change these. Now this plus or minus is going to have to deal with maybe what quadrant it falls into, and we'll look at that when we look at some examples. Okay, so for this first one, find the exact value of sine of pi over 12. So we can't put it in the calculator. We're going to have to use something. So I'm going to go ahead and use that half angle formula, because what I notice is that pi over 12 is really just pi over 6 divided by 2. Right? If I take half of pi over 6, it would be pi over 12. Okay? So using that, we can kind of manipulate it a little bit. So I can rewrite this as sine of pi over 6 divided by 2, or the half angle of pi over 6. And then we can go ahead and set that up. It's going to be, I'm just going to write the general form and kind of fill it out. It's going to be plus or minus 1 minus cosine of pi over 6 all over 2. Okay. Now we can kind of go ahead and simplify this a little more. So first off, it's sine of pi over 6 over 2. If we think about that, that pi over 12, that's in that first quadrant. So we know sine is going to be positive, so we're going to just use the positive version. Okay, so we're going to have this equal to a positive, and you can just write it as a square root, right? Then 1 minus, well, cosine of pi over 6. When we think about that pi over 6, okay, if we're thinking about pi over 6, okay, that would be cosine is going to be that square root of 3 over 2. So this is going to be square root of 3 over 2. Okay, all over 2. Now we have a complex fraction, so I'm going to multiply the top and the bottom by 2. So that's going to give me the square root of 2 minus square root of 3 all over 4. Yeah. Now I can simplify that square root. I can do the square root of the top, which would be square root of 2 minus square root of 3, and that's okay. It's going to kind of look goofy. But on the bottom, if I do the square root of 4, that's just going to be 2. Okay? So there's our final answer. And if you wanted to double check your answer, you could plug this into your calculator and then plug in sine of pi over 12, and it should give you the same answer. Now let's look at this next one. It just wants us to simplify it. So it doesn't want the exact value, it just wants us to simplify it. So using those, we're going to try to kind of manipulate it and rewrite it to something that we can work with. Okay. So I noticed that this is square root of 1 plus cosine of 12x over 2. So that tells me that I'm going to be using cosine because of that plus. If we look at those formulas that we have, the 1 plus cosine one was cosine. It was cosine of x over 2. Okay, but the thing here is we need to figure out what our x value was. Our x value wasn't just x, it was actually 12x. So I'm going to put that 12x in for that value of the angle. So it's going to be cosine of 12x over 2, which we can simplify to be cosine of 6x. Okay, if we look at this next one, okay, I noticed that matches up with tangent. Okay, so I'm going to do tangent of x, okay, but it isn't just tangent of x because our angle is actually 5 alpha. So we're going to go ahead and do tangent of 5 alpha over 2, and we can't really simplify that anymore, so that's our final answer. Now we're going to verify a little bit. So for this first verification one, we're going to go ahead and, when I look at this, I say, okay, well I have 2 cosine of 2x over sine of 2x. I'm going to work with that left side. Right away I notice that it's a double angle since it's 2x. Okay, so I'm going to kind of rework it a little bit. The first thing I'm going to do is I'm going to rewrite the bottom as 2 sine of x cosine of x, because on that first slide we know that this is equal to this. Okay. Now I'm going to just bring down that top part. It's going to be 2 cosine of 2x. Okay. Now I notice that I have 2 divided by 2, so I can actually simplify those to just be cosine of 2x over sine of x cosine of x. Now I can rewrite cosine of 2x. I can rewrite this cosine of 2x using that formula as cosine squared of x minus sine squared of x, and it's still over sine of x cosine of x. Okay. Now I notice that I'm kind of getting close to something that can be tangent and cotangent. I'm going to go ahead and split these up. This is going to be cosine squared of x over sine of x cosine of x minus sine squared of x over sine of x cosine of x. And I notice right away I can cross out a cosine on both of these. I can get rid of one cosine for one cosine, so I'm left with cosine of x over sine of x minus, over here I can cross out a sine, so I'm left with sine of x over cosine of x. And if I look right there, that's going to be cotangent of x minus tangent of x. And that is exactly what I wanted that right side to equal. So using that formula, I manipulated the left side to make it look like that right side. So we verified it.